So now that we have our linked list class set up and we can use it nicely, that is, we set up an instance of this linked list, we insert whatever we need to insert, and this will work for any number of things, and then we print it out. Now let's say we want to do the same thing but with double precision values. What can you do with this? Well, first step would be to convert this to a template, and in Java we call that genericizing your class, but in C++ we call that templatizing. So same kind of idea. So once we can do this, then we can set up a double array and add all those double precision numbers into a linked list of double values, or we can set up our own whatever class, and it doesn't have to be a primitive data type. We can set up our own. We can set up strings. We can set up an array of strings and pass that into our linked list. Okay, so that's what we want to do next. How do we do it? It's not so bad. Pretty much all you have to do is say template and then have a name for this type. So remember, when we set up templates, what we're going to do is, just like with Java generics, we're going to say that now the type of thing that this linked list is going to store is going to be variable. And you can specify at actually at compile time, at actually runtime, what kind of thing that you're storing. So instead of just ints, you can say t here. Okay, so wherever you see an int, for example, put in a t, and that's about it. And assuming that this is defined, that is, assuming that we have overloaded the insertion operator to work with whatever type this is, p-error data, we know that it was an int, that worked. If we use objects for data for this type t, well, you might need to overload the insertion operator. In this case, if you're just using, as we are, ints, we should be okay. So let's try that. Not many changes. Let's see if there's what problems we might run into. Oh, unfortunately, no errors at all. Nothing to debug. So not very interesting. It looks like everything might have just worked. Let's try running it. See if we can run into errors there. Nope, no errors. Unfortunately, or fortunately, everything just worked perfectly. So now let's try to make some errors. Let's say we create a double array, and we'll give it, we want to see the things after the decimal point printed. That will be our proof that everything worked. Because as you know, if you have an array of doubles, you put that into something that stores ints, it'll get truncated if we were storing ints, right? So if I keep this int here, let's see what happens. I'm curious to see. Compile it, run it. Sure enough, all the fractional parts all disappeared. So now, to double check and make sure that we are actually storing doubles, we'll now say that linked list, we're going to use the template parameter and pass in a double, so that now it should be storing doubles. So this time around, when it prints, it should print out 8.6, 52.1, and so on. Let's see if this compiles. Did compile. There it is. It worked. So notice that it took us less than 5 minutes to convert this linked list class into a templatized class that can take any type. And now you can put in strings if you want. Let's try that. Of course, there's a lot of stuff missing. Yeah, let's do this. Pound, we haven't, I just realized we didn't include string. And then we have to say using std : string. And now we have to set up a bunch of strings in here. just putting I want numbers. All right, that's 4, 5, and oh, I'll put in one word. Okay. Let me see if this compiles. Oops. Oh yeah. Forgot to make this define the type to be string. Wow. Alright, so I'm impressed. With just a few changes, we set up the string array, change this from double to string. Everything compiled. May not work, but oh, it even works. Well, a little disappointing that we didn't run into any bugs, but looks like it's so easy to convert this particular class. Of course, it's not doing a whole lot. That's probably one reason why we were able to do things so quickly. So all we needed to do was add this template statement or template clause, say class T, convert the type of thing that we're storing to a T, and then we had to change this. Because of the way we set it up, everything else was perfect the way we set it up. Now the way the book does it, they do it a little bit differently, so I'll just show you that way as well. What they do is they take the struct out of the class. It's not an inner struct or inner class. And they define it outside, and you can do that. You can say, and you can templatize it. You can templatize structs as well as classes, but you have to do a little bit. You have to do some things a little bit differently, and you have to say this is a node, a pointer to a node using the type T. So whatever type T you get here, you're passing that along and saying, well, temp is a pointer to not just any old node, but node using type T. Okay, so since we have, and the T here refers to this T, whatever is passed in, it's forwarded on to this struct. Now I got to do that everywhere. So we're going to say, we have to say this over here is pointer to node using type T. And also here. I don't know if I caught everything. We'll find out. Just save it, compile it. Tons of errors. And what are we? Oh yeah. It's actually just one error, I believe. We forgot this one. Head is also now a pointer node that's templatized. And there we go. Fixed everything. And this is the way the book likes it to do it, is to have a struct outside the class. But as we saw, it's even simpler to have this struct be a private part of this class and not be accessible. If you want to do it this way, well, there's a tiny bit less encapsulation if you have this struct outside, because now it would be possible for the main class to sort of muck around and change individual, possibly change individual nodes. You don't want to allow a client to do that, and so ordinarily I would say, even though the book doesn't do it this way, I would say put the struct inside this class, make it private, make it a private part of this class. That way, no client will be able to access this, the inner details of your data structure. Okay, so we went through a couple of ways of setting up a linked list class. We even templatized it so that we can store all kinds of types. We can store objects. String is an object. We can store ints, floats, doubles, anything you want. And most of this code, there's very little compilation that you need to do. If you're using this class, all you need to do is basically this thing. That's it. And if you are getting data from somewhere else, make sure you got the right type. And essentially, for using linked list, all you need to concentrate is on just using it You say what type you want to store, what type of things you're going to store in it, insert those same kinds of things, and then print it out. Sure, it's a very simple class. That is, it doesn't have many methods. And if we had more complicated methods, like if you had a destructor that actually did something that actually took care of memory leaks, sure, we could run to more complicated code. But this turns out to be very, very, very simple implementation of a linked list.